All right, welcome focus learners to today's explainer. If you've been staring at polynomial factoring and just begging for a faster, more systematic approach, well, you are in exactly the right place. Today, we are officially upgrading. We're moving away from memorizing random math rules, and instead, we are building a completely logical, foolproof math survival toolkit. By the end of this explainer, you're going to have a structured, step-by-step mental framework to completely streamline your math skills and honestly, just master polynomial factoring once and for all. Let's get into it.
So here's our game plan, our mental flow chart for today. 1. The golden rule, which is the GCF. 2. Tackling standard trinomials. 3. Special cases and shortcuts. 4. Grouping, also known as the four-term fix. And finally, number 5, the ultimate fail-safe methods.
All right, Section 1, the golden rule, GCF. This is the first step you must absolutely always take.
Okay, so factoring by the greatest common factor, or GCF, is essentially just reverse distributing. We're literally just scanning the terms to find the largest single factor they both share. So let's say you have the expression 12x squared plus 18x. Well, the biggest number that divides perfectly into both 12 and 18 is 6. And the highest number of x's they share? Just 1. So we simply pull out that 6x. Dividing the remaining expression by that 6x neatly leaves us with 2x plus 3 on the inside of our parentheses. Always check for this first, because it makes literally every subsequent step infinitely easier.
Moving right along to Section 2, tackling standard trinomials. This is your absolute bread and butter. Now, when you're dealing with trinomials, our toolkit's flowchart splits depending on what we see right up front. We have the simple case, where the leading coefficient is just a invisible 1. And then we have the general case, where that leading a term is a number greater than 1. Spotting this difference immediately dictates our very next move.
For the simple case, the goal is basically a puzzle. We need to find two specific numbers that multiply together to equal the constant c term at the end. But they simultaneously have to add together to equal the middle b term. Let's take x squared minus 5x minus 14. Okay, we need numbers that multiply to negative 14 and add to negative 5. A little quick mental math points us straight to negative 7 and positive 2. You just drop those numbers right into the parentheses and boom, the puzzle is solved. X minus 7 times x plus 2.
But what happens when that a term is greater than 1? Well, that's when we rely on the AC method. Instead of just looking at the last number, you start by multiplying the first and last numbers together. You find two numbers that multiply to that brand new AC value and add to your middle b term. And here's the trick. Use those two numbers to split your middle term into two separate pieces. Suddenly, your three-term problem becomes a four-term problem, setting us up perfectly for factoring by grouping.
Which brings us to Section 3, special cases and shortcuts. Let's be real. Mathematicians notoriously love shortcuts, and recognizing perfect squares allows us to skip all those tedious calculations we just talked about entirely. Whether it's the difference of squares or perfect square trinomials, the key is just training your eyes to notice perfect square numbers. You know, numbers like 9, 16, 25, or 36.
So when you see a problem with just two terms and both are perfect squares separated by a subtraction sign, something like x squared minus 36, you don't need any complex formulas at all. Just remember our catchphrase, a minus b, a plus b. The square root of x squared is x, and the square root of 36 is 6. You instantly write out your factors, x minus 6 times x plus 6. It really is that fast. If you spot the visual pattern, you can solve the problem in literal seconds.
And for trinomials, we use what we call the square and double check. Look at the expression x squared plus 10x plus 25. Notice how both the first and last terms are perfect squares. Let's find the roots, that's x and 5. Multiply them together to get 5x, and then double it. Since doubling it gives us our exact middle term of 10x, we know for a fact it's a perfect square trinomial. We instantly factor it as x plus 5 squared, totally bypassing the long AC method.
Section 4, grouping, also known as the four-term fix.
Now, sometimes a problem looks completely overwhelming just because of its length. This is a classic divide and conquer strategy. Just slice the four terms right in half by grouping them into pairs with parentheses.
Then apply the greatest common factor rule we learned earlier to each group separately. For example, factoring out an x squared from the first group and a 2 from the second group leaves us with the exact same binomial inside both sets of parentheses, x plus 3. You just combine the outside terms into one binomial and keep that shared inside term as the other. Group it, factor it, combine it. Easy.
Okay, but we've all been there, right? You run through your flowchart. You look for a GCF. Nothing. You try the magic multiplying and adding numbers. They don't exist. You check for special patterns? Nope. So I have to pose this dramatic question to you. What happens if the polynomial just stubbornly refuses to factor using standard methods?
That brings us to Section 5, the ultimate fail-safe methods for when all else fails.
Our first failsafe is completing the square. If an equation doesn't gracefully give us a perfect square, this method allows us to just build one from scratch. It's basically the mathematical equivalent of forcing a square peg into a round hole.
Let's walk through the exact mechanism of this brute force approach. Imagine we have x squared plus 6x minus 7 equals 0. Step 1, get that unhelpful constant completely out of the way by moving the negative 7 to the other side. Now, we manufacture our own perfect square. We take our middle term, which is 6, cut it in half to get 3, and square it to get 9. We add this 9 to both sides to keep the math balanced. On the right side, our 7 plus 9 becomes 16. And on the left side, well, we've successfully manufactured a perfect square trinomial, which we instantly factor into x plus 3 squared. From there, you just take the square root of both sides, and you've effectively bypassed a completely impossible factoring problem.
And finally, we arrive at the absolute ultimate failsafe in our explainer toolkit today. The quadratic formula. When all else fails, when the numbers are just ugly decimals or fractions, the quadratic formula asks literally 0 questions. It just solves for the roots directly.
The real beauty here is the plug-and-play simplicity of it all. You just drop your a, b, and c values right into the formula. If it runs the math and tells us our roots are 4 and 2, we just work backward to find our factors. We write them as x minus the first root times x minus the second root, which gives us x minus 4 times x minus 2. It's the ultimate failsafe when patterns absolutely refuse to emerge.
And there you have it, folks. You are no longer just guessing in the dark. You now have a completely structured, foolproof mental flowchart. Remember, math isn't about some innate genius. It is literally just pattern recognition. You check for a GCF, you analyze your A term, you hunt for those visual shortcuts, you use grouping for long problems, and you deploy your fail-safes when absolutely necessary. Equip your toolkit, find the pattern, and solve.
Because honestly, the strategies we've learned today, breaking a large, intimidating problem down into recognizable bite-sized components using a logical framework, they apply to so much more than just algebra. So I'll leave you with this thought. Armed with this new systematic approach to learning, what complex, seemingly impossible problem will you break down next? Thanks so much for joining me on this explainer, and as always, stay curious.